All right, let's just jump right into it. For what feels like ages, physics has been kind of stuck, searching for that next big breakthrough. Today, we're going to look at a pretty wild new idea called the Bundy reciprocal system, or BRS for short. But here's the thing. This isn't about some new particle they found or a crazy complex equation. No, this is about a series of, well, profound mental shifts that challenge the very reality physicists thought they knew.
This isn't just coming from the fringes. Even top physicists like Lee Smolin are openly saying that our most basic ideas are probably wrong. When a guy like that says the very notion of space should probably disappear, well, that's a huge clue that we need a revolution in our thinking. So that really is the big question for us today, isn't it? What if, to move forward, we actually have to go all the way back and unlearn the fundamental things we assume about the universe? What if the biggest roadblocks aren't in our particle accelerators, but actually inside our own heads?
Yeah, you hear it all the time from people in the field. Theoretical physics has kind of hit a wall. I mean, despite all its incredible successes, it is genuinely struggling to solve its biggest puzzles. And the biggest puzzle of all? It's the massive glaring conflict between its two greatest achievements. And this right here, this lays out the sheer scale of the problem. On one side, you have Einstein's general relativity. It's beautiful. It describes this big, smooth, continuous universe of planets and galaxies. But then, on the other side, you have quantum mechanics, which tells us reality at the tiny scale is all jittery, discrete little packets of energy. They both work perfectly in their own domains, but they describe reality in ways that are just completely, fundamentally at odds. They can't both be right as they are. So this is where the Bundy reciprocal system, the BRSt, steps onto the scene. And it's radical. It doesn't try to just patch these two theories together. Instead, it says, hey, let's build a totally new foundation from the ground up. But, and this is a huge but, to even begin to entertain this idea, a physicist has to be willing to overcome three massive conceptual obstacles. Three ideas that challenge pretty much everything they've ever been taught. Okay, obstacle number one, and this one is the big one. It goes right to the heart of how we experience everything, the very nature of space and time. So look at the shift in the questions here. For centuries, physics has seen space and time as a kind of fixed stage, a container, and the question has always been, okay, what's moving around on this stage? The BRSt flips that completely on its head. It says motion and only motion is what's truly fundamental. Space and time, they're just effects of motion. So the question becomes, how does motion itself create the illusion of a stage for things to happen on?
And if you want to know just how deep this redefinition goes, get this. The theory introduces something called inward time. The idea here is that time isn't just this one-way street, always ticking forward. Nope. Just like space can expand outward, time can actually contract inward. It can pulse. It suddenly gives time this dynamic quality that is totally alien to how we normally think about it.
All right, if you've managed to wrap your head around that, we're moving on to the second hurdle. And this one takes on Einstein's single greatest creation, the very fabric of spacetime. We all learned that spacetime is a real thing, right? Einstein imagined it as this geometric fabric that can be bent and warped by gravity. It's an amazing idea. But the BRSt comes along and says, that's a powerful illusion. It argues that spacetime isn't a substance at all. It's just a relationship. It's what we measure between these fundamental units of motion when they happen to sync up or resonate. It's not a thing itself, it's just a measurement of a harmony between things. I love this quote because it just nails it. The idea of space-time is just the bookkeeping for how different motions relate to each other. Wow, it's the shadow cast by the only thing that's actually real, motion. So in this view, the stage itself is just a shadow thrown by the actors. Okay, the third and final obstacle. And honestly, this one might be the most mind-bending of them all, because it challenges the most basic, fundamental element of geometry that we all learn as kids, the humble point. So we think of a point as just a location, right? A you are here marker, a dot on a map. BRS throws that entire idea out the window. A point in this system isn't a place, it's a state of being. It's a specific harmony, a resonance of motion. Think of it less like a dot on a grid and more like a specific musical note in a chord. It's defined by its vibration and its relationship to all the other notes. So how in the world do you organize this cosmic music? Well, to structure these resonant points, the theory dusts off this ancient symbol from the Pythagoreans called the tetractes. It looks mystical, but you should think of it more like a mathematical blueprint. It provides a framework for how these harmonies of motion can combine, layer by layer, to actually build the structure of reality.
And this is where things get a little weird, because across all of physics, one number just keeps showing up over and over again, almost like it's a secret code left by the universe. That number is 4.
I mean, really, think about it. You've got 4 fundamental forces. We live in 4 dimensions of space-time. There are 4 quantum numbers to describe an electron. And what do you know? There are 4 levels to the tetractys. BRC says, hey, maybe this isn't a coincidence. Maybe this is a huge clue pointing to the fundamental fourfold structure of reality itself.
So, after climbing these 3 absolutely monumental mental hurdles, rethinking motion, space-time, and even this simple point, you have to be asking yourself, why? Why bother? What could possibly be the payoff for such a massive intellectual effort? Well, the prize for all that hard mental work is potentially everything. It's a chance to finally break the stagnation in physics and solve some of the deepest, most nagging paradoxes we have.
Okay, so what exactly is on the table? First, it might just solve the infamous measurement problem in quantum mechanics. By defining reality as this continuous flow of motion, you get rid of weird paradoxes like the wave function collapse. Second, it offers a real path to a unified theory in our normal 4 dimensions without needing all those extra unobserved dimensions that things like string theory require. And finally, it gives time a real, concrete, quantifiable role at the quantum level, something that has been a huge missing piece for almost a century.
And that really leaves us with this final thought, doesn't it? Maybe the next great breakthrough in physics isn't going to come from a new, more complicated mathematical equation. Maybe, just maybe, it's going to come from a simpler but much harder act, a profound act of imagination, the willingness to completely unlearn reality itself.